All right, everybody, we are back for video number 2 for section 5.2 of AP Calculus, Extreme Value Theorem, Global versus Local Extrema, and Critical Points. This video is going to focus on critical points, since we almost got the rest of the lesson done. So we're going to talk about what a critical point is and how we are going to find them. So here we go. We start with a definition of what a critical point is. A critical point is a point in the interior of the domain of a function at which the derivative is either equal to 0 or the derivative does not exist. As long as there is a point there where f prime equals 0 or f prime doesn't exist, then it's a critical point. Now it's possible for us to have places where the derivative is equal to 0 or undefined, but that the function doesn't exist. So a key part of being a critical point is that there actually has to be a point on the function there. And you'll see somewhere you have to weed those out, not necessarily in this example, but as we progress through the course. So let's go ahead and look at example 3. We're going to find all the critical points of the given functions. So we're looking for where the derivative of the function is equal to 0 or it doesn't exist. So the first thing for us to do is find the derivative. So let's go ahead and find f prime of t. And I take the derivative of this, that's 6t squared plus 6t minus 12. Now this is a polynomial, so I know that it's not going to be the situation where the derivative does not exist at all. So we're strictly looking for where the derivative is equal to 0. So I'm going to go ahead and set the derivative equal to 0, and I'm going to solve for t. Man, would it be real nice if I could factor this. Let's see, that's 6 times the quantity t squared plus t minus 2. Oh, looks like I am in luck. I also possibly could have done that, using the quadratic formula or graphing it on my graphing calculator and solving. But we find that the t values where the derivative is equal to 0 are -2 and 1. And so when we're talking about critical points, these are the locations of the critical points, but the critical points themselves are points. So I'm going to take these time values and plow them back into the original function and see what the y-coordinate is to get the full critical point. I substitute -2 in here. Let's see, that's -16 plus 12 is -4. That's 0 plus 24. So it looks like -224 is our first point. And we substitute 1 in here, and we've got 2 plus 3, that's 5, minus 12 is -7, plus 4 is -3. And so there are our critical points for this function. All right, now we'll do the same thing for q. We're going to start by taking the derivative, q prime of x. And I'm going to go ahead and use the product rule here. So I've got 3x times the derivative of the quantity x plus 4 to the 2/3, which is 2/3 times the quantity x plus 4 to the -1/3, plus x plus 4 to the 2/3 times the derivative of 3x, which is 3. Now myself personally here, I'm going to go ahead and shift this into one single fraction because it's going to be so much easier for us to find the critical points of this if we set it up as a single fraction. So the first step in doing that is I'm going to simplify this to 2x over the quantity x plus 4 to the 1/3 plus 3 times the quantity x plus 4 to the 2/3. And then I'm going to put that over the common denominator. Quantity x plus 4 to the 1/3. That leaves the 2x as it is, and then I multiply this term by the quantity x plus 4 to the 1/3, which makes it just 3 times the quantity x plus 4. And so I can simplify this to 5x plus 12 over the quantity x plus 4 to the 1/3 power. Okay, now I want to solve this. Q prime of x is equal to 0 whenever the numerator here is equal to 0. So I set 5x plus 12 equal to 0. I solve for x. I get that x is equal to -12 over 5. and q prime of x is undefined whenever the denominator is 0. And so I set x plus 4 equal to 0, so x is equal to negative 4. And as long as these are points on the original function, I'm going to have critical points here. So I'm going to find the y coordinates that go along with these. If I substitute negative 4 into the original, I'll do that one first because it's easier. 3 times negative 4 is negative 12. Negative 4 plus 4 is 0, so we have 12 times 0. So the point negative 4, 0 is our critical point. And then the other one is negative 12 fifths. And I'm going to go ahead and use my calculator to do this one because I know that this one does not come out nicely. So I'm going to go ahead and we'll put, let's see, 3 times negative 12 fifths times the quantity negative 12 fifths plus 4 raised to the 2/3 power. And let's see what I get here. Negative 9.849 is going to be my y coordinate. And I'm just going to go ahead and write that as the decimal. So those are my critical points. So that's what critical points are and how we find them. And you're going to go through a process similar to that anytime that you're finding a critical point. All right, that's the end of this video and the end of the lesson for section 5.2. Come back and join me next time for section 5.3, where we will talk about determining intervals on which a function is increasing or decreasing. All right, have a great rest of your day, everybody. See you next time.